First, I will give you some context about why we need to build CI/CD pipeline. Then I will introduce you to how to leverage AWS to build the CI/CD pipeline. There are several AWS services are needed to make this pipeline to work. We will dive into more details shortly. AWS provided multiple ways to build the pipeline, and I will demonstrate how to use Terraform to implement it. Last, I will open up for questions and share some afterthoughts about the project. Let's talk about some challenges of code deployment lifecycle. In the past, a developer usually first built the application locally, then run the unit tests to ensure the quality of code meet the requirements. Once the code is ready, the developer will package the code and send artifacts to the server. This is a very manual process and can be problematic. For example, the application may work locally but not on the server due to the environment differences. This manual process can be automated using CI/CD pipeline. Here's the system diagram to illustrate how the CI/CD pipeline works. I will walk you through it and explain it in more details along the way. First, the developer pushed the code to the GitHub repository. AWS CodePipeline got triggered and started to pull the source code and store the code into the S3 bucket. Second, the build stage in the pipeline began, and the AWS CodeBuild services built the code and sent artifacts to the S3 bucket. The pipeline then triggered the deployment stage, which was implemented by the AWS CodeDeploy service. The CodeDeploy service first got artifacts from the S3 bucket and deployed them to the EC2 instance, our application server. End user will be able to access the application then. There are three AWS services used in the CI/CD pipeline that we didn't see in class. As we see from the previous diagrams, the CodePipeline service manages the source, the build, and the deployment. The CodeBuild manages to build the application and run tests. CodeDeploy manages the deployment of artifacts to the final location. In the class, we have seen the benefit of using Terraform to create AWS infrastructure. Here, I'm leveraging it to build the CI/CD pipeline. Below is my Terraform project structure. Main TF file builds the EC2 instance. The network TF builds the VPC. The CodeBuild builds the CodeBuild project. CodeDeploy TF builds the code deployment application. Lastly, the CodePipeline TF builds the code pipeline. Now, let's see how CI/CD pipeline in action. This is the final project demo written in Java. The source code is stored and versioned in GitHub. We choose to store the source code in GitHub because it's widely used for source control in either personal or enterprise settings. Similar to our Terraform assignment, we can sign up a free-form GitHub account and create a blank repository to begin our setup. In this project, we're going to build a Java application. The source code is part of the examples provided by AWS. So we first create a class that's under source main Java folder. Name it message utility.java. This is the source code. All it does is just print out a message. It's a very simple example. Second, we're going to create a test class file under the source test Java folder. Name it test message utility.java. This is the source code. This class performs a unit test. Third, we are going to create a POM file. It is an XML file that defines the project and then packaging and then dependencies. Until now, we have created a Java application for the demo purpose, but in order to allow build and deploy the application using the CI/CD pipeline, we have to add a few more files. The first file is build specs.yml YAML file. It is used during the application build stage. We need to put this file in the root directory of the repository. Here is the source code. As you can see, it defines when the server starts, what kind of environment to be installed, and what command to be run during different stage of the build. Lastly, what artifacts to be exported and saved into the S3 bucket. The second file is the app specs YAML file used during the application deployment stage. We need to put it into the root directory of the repository as well. Here is the source code. There are a few shell commands that need to be created, highlighted in the app specs YAML file. These are the house cleaning commands to keep the destination EC2 server clean while applications stopped or start. Those are the scripts that use to either fix privileges, make sure we have proper permissions, and then we have to clean up the application directories and set up when the application start, navigate and start Java, and when stop Java. Here is the list of files in the demo project source code repository in GitHub. The source script folder, the source, the app specs YAML file, build specs YAML file, and POM file. In this project, we are using Terraform to create the CodeBuild project instead of AWS Console. Here's the source code to create CodeBuild project. We have to note a few things. First, artifacts. This is the location where the artifacts will be stored. I have created an S3 bucket to store the artifacts. This is our S3 bucket names. Environment. The environment is where the application will be built. The build specs that we just saw in the source repository will guide how the application should be built. The type attributes indicate we choose a Linux container, and the image attributes specify the Linux image version. Source. Since we're using GitHub as our source code repository, we'll specify the source type as GitHub, and the location is the Git URL of our demo application. As always, we need to specify the IAM roles and policies for the CodeBuild project. First, we must create a service role for CodeBuild with the following policy. It needs to access the CodeBuild services. Second, we must create a policy used in the trust relationship with CodeBuild. Important note is that we need to grant permission for the log and the reporting actions. Also, we have to grant S3 bucket to get and put permissions for our CodeBuild project. The last one is to attach the CodeBuild policy to the service role. CodeDeploy. CodeDeploy. Once the application is built, we need to deploy it to the EC2 instance. CodeDeploy service provided the necessary tool to deploy the source code to the application server. First, we need to create a CodeDeploy application. This is the code to create the application. Deployment group. We need to create a deployment group which specify the destination where the artifacts will be deployed. Here is the source code. The deployment group uses the EC2 tag to identify the destination EC2 instance. In our case, it's called default public web EC2. And then if we navigate to the source code of EC2 creation, we can see that this is our tag for the EC2 instance, which matches what's defined in CodeDeploy. Third, we must create an IAM service role for the CodeDeploy deployment group. It needs to access the CodeDeploy.amazonaws.com service. Fourth, we must attach the AWS CodeDeploy role policy to newly created service role. Fifth, we must create a service role to allow access to EC2 service. Let's highlight here. Sixth, we must attach Amazon EC2 role for AWS CodeDeploy policy to EC2. This role is needed by the CodeDeploy agent on the EC2 instance. CodePipeline. CodePipeline provides a continuous delivery service to release the application automatically. This is an important part of the CI/CD pipeline. It glues the CodeBuild and CodeDeploy service together seamlessly to automate the application release lifecycle. Artifact store. This specifies the artifact location, which is our demo project in the S3 bucket. There are 3 stages in the code pipeline. First one, source. Since we're using GitHub as our source code repository, we have to create a CodeStar connection between the AWS service and GitHub providers. We can find the configuration under the settings, connections. This steps is that you cannot complete using Terraform alone. We must use AWS console to authenticate and connect to our GitHub account. Otherwise, it will always show pending if you create it in Terraform. In this demo, we're using AWS console to create the connection ARN and supply it to our Terraform code. So this ARN will be used as the connections between the GitHub and AWS service. In the source providers, we can see here CodeStar connection, source connection. And then here is the configuration for that connection, the ARN that we just reviewed. And then the repositories, IDs, and then branch name of the GitHub repository. The second stage is the build stage. In this stage, we're using CodeBuild as the provider. Here is the source code, and then this is the folders that for the input, and this is the folder for the output on the S3 bucket. Lastly, deploy stage. In our demo, we will use CodeDeploy as the provider and supply the CodeDeploy application and deployment group created in the previous step. Finally, for CodePipeline, we have to set up the IAM service role and policies. I use the AWS console to create the roles for the code pipeline. So we have to create the following IAM service role for code pipeline. You have to set up the trust relationship for it to access the CodePipeline services. With the permissions policies, there are two permission policies had to be specified. The first one is CodeDeploy policy. In this one, it needs to access the CodeDeploy, have the CodePipeline to be able to access the CodeDeploy, the EC2 service, allow, and then auto scaling. Another policy you have to create is allow the code start connections to access the S3 bucket. This is very important to note. There are a couple of additional configurations need to be done on the EC2 instance in order for the CI/CD pipeline to work. I implemented in the EC2 creation process. So here's the code to install the CodeDeploy agent. Since we're running Java, so I also initialize and set up Java while creating the EC2 instance. Finally, in order for me to access through SSH to the server, I have created the AWS key pairs to allow me to remote access to the server. In addition, to allow EC2 instance connect by specifying the IP address of the EC2 instance connect. Finally, let's get the ball rolling. First, let's run the Terraform init. Second, let's run the Terraform plan to view what will be created. The VPCs, the EC2s, CodeDeploy, CodeDeploy service, CodeBuild service, and CodePipeline. Okay. So let's run the Terraform plan. Let's go to the console. The pipeline has been created. Sometimes we notice it will have had some issues with the sequence when which one create first. And it says some project cannot be found, but indeed it has been already created. So all we have to do is retry it. So here is the code pipeline, the source stage, build stage, and deploy stage. The build stage sometimes take a minute to complete. In the meantime, we can look at the EC2 instance where we can validate, make sure our code has been deployed to our web server. And we have two ways to connect. Let's try the instance connect. Okay. Still building. Just give some times for it to complete. Okay. Now the build stage completes. Final stage, deployment stage. In this stage, the code deploy will get the source code artifacts from the S3 bucket and then drop it to the EC2 instance that's been defined in the steps. Okay, success. Now let's go back to the EC2 instance that we just connect to, and let's review our applications. Let's first browse to the application folder, and then let's list the files. As you can see, the message utility jar file is our application. Now let's run it. Voila, we have the message displayed above this course. So we have seen the source code being pushed from GitHub all the way to the server. Let's see how if we make a change in a GitHub repository, what would happen. Go to the code. Let's make a change, our display message. Save this change. Now let's push this change to the GitHub repository. Submit the change, push the changes. Okay, so the change is pushed. Now let's look at the pipeline. As you can see here, our source just updated now, and then our build process kick in. It's trying to build the updated applications, and we can see the source, the message has been updated, reflect our latest change, update message 2. Let's give some time for it to finish. Okay, so the build success. So now is our last stage, deployment stage. Depends on the size of the application. Sometimes can take a while to transfer the file. In real project, you will see these steps also takes, the build takes most of the time, deployment takes second, source update usually it's instantly. Okay, so now all three stages completed successfully. Now let's go back to our application and let's refresh our list of file. Wait a little bit. Okay. Okay, so here's updated files. You can see the timestamps have been updated. Let's run applications. Well done, class 2022. This concludes my presentation. Thank you. Now it's time for question.